Hello. All right. Um, we're back. We're going to keep working on. And last we left off, which is a few hours ago, um, we have just added support for decoding data from strings or any other value if you use a custom strategy. And I think we've finished that part. So this time I thought about some more with regard to dates. And this is JSON decoder's implementation. Um, the aspect of including is is growing on me. I think in reality, at least in my personal experience, I've seen a lot of um, unfortunate use of timestamps as to encode time, to indicate time. Also think that using a formatter makes a lot of sense. Although that's going against the purpose of using TOML to begin with, right? So on one hand, on the practical side, um, I've seen usage of all these kind of weird formats, but it's all in the world of JSON. On the other hand, yeah, TOML really, why would you use TOML if you want to use your custom date format at all? So I guess ultimately, I probably won't, at least in 1.0, include any weird date encoding options. Hi, Carlos. By the way, my streaming computer is over here. So when I'm looking in this direction, that means I'm looking at you, chat. Okay. Yeah, so I guess all that is saying we're going to stick to our plans here. And I'll keep this notes here to think about it some more. But for now, I want to add decoding strategy for keys. Because right now, what you see is what you get. As in, your key, the key in your Swift object must match that found in your TOML. So that's not great because in real world, there's people use all kinds of formatting for their strings, keys, and in Swift world, we use camel case. Yeah, but this part should be easy because it's being decided that we're just gonna again steal from JSON decoder. So in JSON decoder, there is key decoding strategy. You have all this. You have use default keys. You have convert to snake case. You have the custom strategy. And convert to snake case is implemented in, some pieces of it is using foundation, but that's fine because JSON decoder supports foundation and includes foundation. Yeah, so I guess long story short, right? We're just gonna steal this. Oops. Yeah, so here are our strategies. We'll steal this one, trim all those trailing white spaces. And I don't like this bit. Yeah, everything else I'll keep as is. This also has the advantage of your meet of how this strategy works when it deals with keys encodings. And this part is weird because why would you do it like this as opposed to this, right? So you have a map, you use the value, so you can do this, put this all in one line. Instead of writing this longhand, you can simply say this. Oops. And then instead of using an intermediate result variable, you can just return it. So now no functional changes, just style editing. I suspect all of this can be slightly nicer, but you know, I can't complain, right? I got it for free, so. It's slightly weird that this is encapsulated in the strategy object. I guess that's fine. I want to variable down a little bit. And then I'm going to add our variable. I think that needs to be moved down as well. Oops. Okay. Key decoding strategy. I guess before we move on, we should test out how this works. It's also good, I guess, for you, my audience. So let's say you have a key A_B, right? Your encoding will fail. Well, first of all, let's change this to a simple thing. A will be an int 64. Yeah, so if you decode it like this, your decoding will fail because decoder won't find a key under A. Or even I can say AB, right? But if you specify that you want the snake decode strategy, this guy, then I think this will work. Hello? Yeah, so now your decoding succeeds. Yeah, so this is the effect we want to achieve. So why don't we encode that, LOL. Let's make sure the code we added compiles first. There's some weird stuff. Convert to snake case. There's a typo. Oh, that's why they are. Yeah, so this is why I don't like it being here. It's noisy, right? You're reading, Like if imagine your code, your reader reading the source code, you're like, oh, some strategy, nice. So this is for strategy number one, number two, number two for this strategy, and then you go here, it's like boom, a big long method in your face. It's like what's coming after next? That I don't know, right? It's weird, weird breakage in the flow. So instead, I'll do it this way, please. Key decoding strategy. So we'll just put it in extension here. It's still file private, so it should be okay. In addition, within this namespace, we have a name and that typo. Let me fix that typo first. Wait, what was that about? User info. Wait, when did this change? Oh, did I accidentally delete user info? Yeah, I did. Data decoding strategy. Oh, I deleted all of this for whatever reason. Oops. Okay. Use of down on the key decoding strategy. Invalid redeclaration. Okay, let's deal with the redeclaration. I guess we'll use a fun name here, right? So that deals with the name collision. At some point, we'll need key decoding strategy. Key decoding strategy. Self.key decode. Okay. Typo. Key encoding strategy. Encoding. Oh, did I copy the wrong thing? Whoops. Key decoding strategy. Wait, was it the wrong thing? Oh yeah, definitely wrong. Definitely the wrong thing. Some white space errors here. I mean, just look at this. What's up with this indentation? think most of these are correct. I guess the description wouldn't be correct. So I'll just copy it again. It doesn't hurt. Right. Key encoding strategy. Key encoding. Key decoding strategy base 64. Strategy. Strategy. Yeah. It will be use default keys. Okay, we compiled. Yeah, that was actually the wrong order of things. That's why I was like not comfortable. I want to write a test first before I'm going on. Not that I'm like very prescribed to. In this case, it makes a ton of sense. Without a test, you never know what you're doing. Code. So. All right. So test decoding key, I guess snake case key strategy. Fine. Sorry, the white space bothering me. Extra white space. Okay. What example should we use? Let's use our player example. Our player at some point should have like a 2-word property, something like a sign up date, favorite date. Yeah, something like this. Okay. Actually, how about this guy? So this is our object. This is our TOML, except this time I'm gonna make it so that it has weird keys. I imagine the mixed casing should be okay. All right, and oh, unfortunately that guy is supposed to have error, so we don't have fixture there. That's fine. We should have a sign update somewhere, and it is here. All right, let's use this date. Okay, this is date time offset date time. That's not enough. We need to take the expectation. We don't care about health. We don't care about any of the date time stuff other than update. Okay, so we expect after decoding, first, decoder will succeed, and secondly, it should have these content. now we just copy another piece of the standard test structure and make this a player. Oh yeah, so this test will fail. And what we want is decoder dot key decoding strat convert from snake. Wait, what do we call it? Convert from snake case. Right. So if everything works, this test should pass. Something's wrong with my stream. I'm camera. I'm dropping 62% of frames. Why? I don't understand. Okay. I'm just gonna ignore it, and if it gets better, lucky for us. So we're streaming at a higher bytes per second, which isn't a lot. We are losing a little bit of packets. On stream because according to OBS I'm like of frames. Oh my god. Alright, let's go back to writing code. What's interesting is the lost frames are so stable. The ratio. I'm gonna restart the stream and keep the recording going. Sorry. if you're watching this, I apologize for this long pause. Hopefully it won't take too long. And why don't you like and subscribe? Wink. All right, I restarted the stream, so hopefully whatever issue we had gets fixed. 0% after like 600 frames. All right, I'm gonna call it good then. So all I did is restarting the stream. I didn't even stop recording in OBS. Okay. Ooh. Where are we? We wrote a test that deploys convert from snake case key decoding strategy. And if we run the test, it should fail. Well, first of all, it didn't compile because datetime requires date. I'll just use date time. Date time. Name time. You know, school of Dave DeLone specific date is a terrible name. I understand the reasoning. It should be called an instant or a moment or something like that, because date implies blah blah blah, right? That's all associated with calendars and all that. And the actual date is at least the date type from Foundation is actually imagine time is a infinite line stretching both a two-dimensional world, and you pick a reference point, and then that is your date. And more specifically, there's actually another relative reference point for date time, for date in Foundation, which is the reference date, which is 2001 epoch. So you have 2 points, and that all the information date conveys. It has nothing to do with any calendars or technically any. I mean, it does have the fact that the marker is kind of, if you want to express it in words, you have to frame it as in a calendar, but it doesn't. It's not necessary, right? It's just some point. Real world conception into that point is your business. You can say this is Japanese calendar, this month, this moment, this second, that's equal to 2001, and then you're back to the world that date describes. All right. Anyways, I was ranting about. I was thinking out about the naming for daytime in nighttime library, but I digress. But yeah, by default, if you don't say strategy, wait a minute, something doesn't feel right. I should be able to ask for a date here, right? Cannot convert value of type datetime to expected argument date. What? Date. This is the date time. Oh. Error thrown here, not handled. Okay. Let's handle it. I keep forgetting to save. I recently changed my key binding such that exiting normal mode doesn't save anymore. Okay. Now the test compiled and failed. So now we can go ahead and implement this. Again, by implement I mean go ahead and steal it, right? So it looks like the key conversion happens as soon as we create the key decoding container. So as soon as this is usually if you are writing your own decoding conformance, you would ask the decoder to give you a key decoding container. And in that, you pass in the decoder itself. And at that moment, your key gets converted. I guess that makes sense because the key container knows that it's a dictionary, so it can go ahead and iterate over all the keys, right? But all that matters here is the fact that we can just straight up copy paste it. So I too have a keyed decoding container somewhere. Yeah, its initializer right now is very simplistic. Now it's less simplistic. So I need to look at what this actually is. So container is assigned there. Here in the convert case, we create a dictionary again by mapping over the container. We have the key value. We have custom, which is very similar. Again, this code is all valid and great, but the style can be improved, right? So the way I would write this will be container, and then we start with a new line, and then I'll throw in the map. And since container is a dictionary, so map key and value. You can now say JSON decoder case strategy, blah blah blah. We call that method. I think we named it snake case of something like this, some goofy name. So instead of doing this, you can say, I mean, this is clearer, I guess. I think there are two ways you can write this. You can write $0.key, hopefully, if the autocomplete actually stop being so helpful. Actually, it's, in this case, the autocomplete is actually working. Okay. I'm a little impressed by that. Right, so I will do this, and then I'll feed the result into a dictionary. I see. So the original code is not that bad after all. All right. Dictionary would be shorter. Nah. Okay. Snake caseify. And we won't have JSON key here. Instead we have TOML key. This still this part might be still nicer to say $0.key. $0.value. Yeah, I think this, I mean, personally, this is purely style choices, is irrelevant. But I think starting each argument in a new line for long arguments like this looks nicer this way, a little bit. A little bit shorter. $0 TOML key string value int string value convert first, second. All right. Okay. So at the moment we create a key decoding container, we will perform the convert from snake case thingy. And now our key should be converted. And now, if this compile at all, I would say JSON decoder. Oh, what? Oh. Now let's come over here and run the tests. And it passed. And that is that. Nice. The only thing that's still missing is we added also the custom strategy where we take a converter. So let's study it a little bit. So here we're taking an input coding key and outputting another thing that's a coding key. What's the requirement of a coding key though? Coding key is simply that little object that could be either an integer or a string, okay? It is that we take the original key, we take the original key in the container, we take the key value, we create the wrapper, we wrap it, and then we make it in the new coding path, right? And then we pass this whole thing, the entire path from root to where we are right now, to the converter function. And converter function will give us a new thing. And then we use that. Okay. So we call convert. And we make a new pair out of it. All right. And this is the value of the pair. This is the key of the pair, and this is the value of the pair. And this is the end of the map function. I mean, the problem with this code that looks this hard to read is this long line, right? fine. I don't think that was much better readability wise. Okay. Yeah, at least this time the stream is holding up. Okay, so let's attempt to write to use it. Right, let's write a new test. So test decoding custom key strategy. We'll take the whole thing again. I see the problem here. We're testing the key, but we're picking like the most complex form of values. How about profession? And we'll just call it a string, right? And I don't know, cook. First profession. Oops. First profession. Okay. First profession. I didn't save, did I? Okay, fixed up that one. Yeah, now it's shorter, it's easier to understand. I like it. So let's say we want all uppercase and we want just this. And we, for now, comment out the strategy thing. I believe this will fail, this particular test. Yep, key is case sensitive, which is a good thing. So now we can go ahead and write our custom strategy. Again, our input is a list of code paths. Coding path. And our output is one single coding key. So guard let, I mean, this is a test, so I'm gonna write it in a janky way. Coding path dot last. And then key dot lower case key dot string value, I think. Lowercase. Let's look at that again. String value. we take the key, we take his string value, we lowercase it, we return another key. So again, that can also be written as coding pass dot last dot, you know what, I can do better. String value lower case map coding key init this guy and we'll return. Can I like throw errors in here? Oh, coding key cannot be instantiated. Great. Okay. Yeah, so I cannot call this directly. I guess I'll. Alright. I'll do this instead. Wait, what is this? How can I access the type of the synthesized coding keys? Wait, something I should be able to do. Wait, this is new. Oh, okay. It's custom string convertible, but is not expressible by string literals. So I should be able to access it as key, right? Or decoder dot. No, we're not inside of the definition of the decoder. Select custom key decoding strategy. I feel dumb. I'm gonna drink some tea. Oh, any coding key. Is this something I have? Interesting. So looks like we're forced to type erase the key, the coding key value, which is not great. Not great. Yeah, so this end up to be very painful to use. So this tells me that this is a gap in usability that needs addressing, right? Coding key is a protocol, so we can't use it as a value type. So we can't create value from it. The coding key type is synthesized for us, so we don't have access to it. But when you do use a custom key decoding strategy, you end up needing to create value for that type that you can't access. That seems bonkers. Trying this thing. Let key equals coding pass dot last. Type of key. Oh, maybe I can do this. Okay. So with type of, this kind of works. The only downside is our value, our expression is no longer 0.3. That's okay. String value, we pass in key dot blah blah blah. I guess. And that test passed. Not surprisingly, but I'm glad that I learned how to write a custom key decoding strategy. Interesting. All right. Well, that took longer than expected. Done with that one. Now we're down to improving the errors. So let's take a look at where we are. So we have tests that proves that we can decode normal objects, nested objects with custom decoding implementations. We have that verifies the strict decoding number strategy and strict decoding date strategy. We have decoded both the net time dates and foundation dates and foundation date components. We have test that verifies data decoding for both the base 64 strategy as a custom decoding strategy. We have key decoding strategy with default type converting from snake case type, as well as custom coding strategy. Nice. So functionally wise, sorry. Whoa. So I was saying, functionally, I think everything is in place for a release. we need to address some really bad, say it's kind of ready for testing. And the issue being these guys. So if I need to search for it, I would search this. There are 13 occasions, looks like. Wait, no. 1, 2, maybe 4 occasions. Yeah, okay. Where I just really bad Python programmer and Swift programmer. Okay, so we need to replace this with proper errors. They're string because they were thrown like early on while I was still exploring the project as opposed to really writing it. So let's look at what JSON decoder throws. So when you call decode and the decode fails, looks like we're calling, by way, JSON decoder would report, data corruption. Wait, something is wrong here. Hold on. So data corrupted. Here's the context. We don't have any keys to give you. And the given value is not a valid TOML value. The underlying error is this error. And this error will be actually pretty nice because it's going to be an error from TOML decoder. So that takes care of the decoding part. Next error we throw is to complain that top level is not found. The given data did not contain a top level value. Okay, that took care of that. Yeah, I think these two methods are identical. And I believe JSON deserializer, this guy, just secretly converts the data into a UTF-8 string anyway. So we can take a look at it. TOML deserializer. Wait. Yeah, as you can see, it simply takes the data, convert it into a string, right? So maybe let me think about this. Do I want to support data in this format or just straight up saying data? Because now we directly support the data type, right? So instead of using the generic parameter trick, I can straight up declare I support decoding foundation data. Now I can say data dot string, I believe. No, string. No, okay. How about string? I never remember like converting between these two. I never fully remembered which one to call. Data. Come on. UTF-8. So it would seem that if we have text as the input, like so, then I can replace that this implementation with this, and this is fillable, right? So I'll do a similar thing here, except I'm really calling this. So the version that takes data actually just converts data into text and then call the version that takes text. Now you can call either one and achieve the same effect. And the text one is actually slightly more performant. I'm sure there will be things such as this. Oh, I made a mistake. What really needs to happen is like this. Hold on. This is what I meant to write. Okay. So in the actual implementation, we throw two strings here. We'll keep stealing container keyed by. This is encoding version, and this is the decoding version. We expect the top level container to be a table. Otherwise, we'll throw this error. Value not found. Coding path, everything should just work. And later for onkeyed container, we'll do the same thing. Onkeyed container. Throw this guy. All right. And then we're done. And then we're left with the contemplation of something that we probably will never support, which is custom date strategy, where you somehow invent your own scheme to represent your date in your TOML data. It's like, why would you choose? If you're supporting some legacy API and use TOML as a transport protocol, first of all, crazy that you have a legacy API that returns TOML. Secondly, you probably shouldn't have used TOML. JSON is fine in that case, and you're stuck with it, and you should admit it and be happy. Okay, what did we accomplish? This is, wait. Just fix errors, right? Remove stringy errors. Throw real error. Okay, we have we have come very close to a working decoder. In fact, I would say is working now. It's probably good enough for most use. The missing pieces now is documentation, infrastructure for the project that can verify that it works on Linux and stuff like that. And then a release so that it's accessible to different platforms, managers, and things of that nature. So I'm going to